All right, welcome back. So from yesterday, we did an introduction to the sine function, and we also did the transform sine function. And then I did a bunch of graphing, but I went really quickly through graphing. So if you understood that, awesome. If you don't understand that, today we're going to spend most of the entire video will be on graphing sine functions. Okay, so now if we had a transform sine function, the only thing you need to know is your values of a, b, h, and k. So once you know what a, b, h, and k are, it becomes very easy to graph it, right? So we'll go through a couple examples just so you get to see what I'm talking about. So example one, let's go with y is equal to 1 minus 2 sine pi over 2 x minus 3. Okay, now if we had that as our function, we know right off the bat that a is negative 2, right there, negative 2. We know that b is pi over 2. We also know that h is 3. And lastly, we know that our k is 1. Now, this tells me everything I need to know. K tells me that at the height of 1, I will have my 3 dots. Doom, doom, doom. That's what that K tells me. My midline is going to be at 1. The A tells me that from that midline, I have to go up 2 and down 2. So I have to go from 1 up to 3 and down to negative 1. So now I know what to make my y-axis. I have to go up to 3, to 1, and I have to go down to negative 1. That's going to be my amplitude. Okay, so here's my x-axis. Now, before I plug in my x values, I'm going to figure out what my period is, because the period tells me where to start, where to finish, right? Well, this actually tells me where to start. I start at 3. This will tell me where to finish. So if I do period equals 2 pi over b. Remember, that's a formula from yesterday. So that's the same thing as 2 pi over 2, which is the same thing as 2 pi times 2 over pi. So the pi's cancel each other out, and we get a period of 4. So p is equal to 4. So if p is equal to 4 and I'm starting at 3, that means I have to go from 3 all the way up to 7 for one complete interval. So 1, 2, 3, 4, 5, 6, 7. Let's go to 8 to make sure. 3 and 7. So I know I'm starting at 3 and 1. So at 3 and 1 is 1 dot. Okay, now at 7 and 1 is my last dot, because period is 4, so 3 plus 4 is 7. So halfway in between is my other dot. That should be in a straight line. That's probably crooked. That's way crooked. Holy smokes. Okay, boom. Now the negative 2 tells me instead of going up first, I go down first. So in between these two, I go down 2. And then in between these two, I go up 2. Now this is the next part is where I skipped over a bunch yesterday, right? Once I got these dots, I just generated my curve. In order to get the in-between dots, we know that the sine of 30 degrees is a half. Okay, we know that because we've done that repeatedly. So that means that from here, if I go 30 degrees over, I should be halfway between that distance. Okay, I'll use a different marker for this part. If I go 30 degrees over, I should be halfway between the distance. 30 degrees, this is 90 degrees. This is 180, 270, 360, right? One complete interval. Think of it that way. So if that is 90 degrees, 30 degrees is a third. A third of the way, I've already covered half of that. Okay, and then another third, so sine of 60, we know is root 3 over 2. If we take root 3 over 2 times 2, we get root 3, which is over here. So once we have those two dots, we can just mirror it on the other side. Right? The key is that knowing that the first third gets you halfway. Okay, the first third gets you halfway. So now we can go, okay, boom, boom, gentle curve at the bottom, which means it is the same thing here. So first third gets you halfway, first third gets you halfway, and then gentle curve up, back down, right? So that is the graph for that because it has an amplitude of 2, or negative 2, I should say, because it goes down first, and it starts at K is our horizontal 1, H is our shift. Okay, so if we continue to the other way, here is the halfway again, so it would be there, there. So if we go backwards, this is what we would get. Right? So 1, 2 are over here, it'd be down here, so it would go down, back up, like so, like so. Okay? All right, example 2. Note to self, Kleenex doesn't clean as well as paper towel. Let's do 3 examples today. Oof. Let's do 3 examples today. By the way, if you're wondering, I'm in my basement. Whiteboard that I bought and made up. And I'm standing over my kitty litter box, which is pretty stinky right now. Anyways, the things I do for you guys. Okay, so example 2. Y equals, let's come up with a one where you have to figure out to be 2 minus 3 sine pi x plus pi. All right, so before we can go through and just say, okay, that's A, that's B, that's H, that's K, we have to do some factoring. We did this already. We're back in October, I suppose, maybe November, where you're given a function, you have to factor it out to find your B. If you don't factor it out, you don't find a true B or true H. Okay, A doesn't change. A is negative 3. B, however, we have to factor it out. So this actually becomes y equals, if I rearrange the whole thing, sine of pi x plus 1 plus 2. Right? I move the 2 to the back and I factor out the pi. So now I know my B is equal to pi. I know my H is equal to negative 1. And I know my K is equal to 2. All right. So now that I have my 4 parameters, let's solve for P, period, first. So 2 pi over pi, which is B, gives me 2. So I know that I have to go across an x domain of 2 to get the full curve. And I also know that I'm starting at negative 1. So if I do a quick little graph, boom, boom, I'm starting at negative 1, 1. So that starting here, 1, 2, period of 2. For this one, let's just do 2 full periods. All right? Now, the K tells me that I have to go to 2, 1, 2, but then I also need to make sure I have 3 more spaces. So I have to go all up to 5. 5, 1, 2, 3, 4. So there's my 2. 1, 2, 3, 4. So that's my negative 2. Now that I have my scale all in, now remember, this scale and this scale don't have to be the same, right? As long as the gaps here are the same and the gaps here are the same, that's all that matters. So K is 2, so therefore along the 2, I will have my 3 dots. Where is my first dot? Negative 1. At negative 1 and 2 is my first dot. And then the next dot, go over 2. So 1, 2. So boom. There's the end of my, why am I so slanted? So there. Start point, end point. So midpoint has to be in between them. So inside there, I have to have a curve. Positive curve or negative curve? Negative curve. So I'll go down first, down 3. So 1, 2, 3. In the middle, boom. Same thing. In the middle, up 1, 2, 3. Right? And now we go to the, okay, we know that the first 30 degrees gets you halfway there. So the first, a third, so halfway was, this was halfway. So the first third got you halfway there. Well, halfway of 3 is 1.5. So 1.5 is here. That's not quite a third. The third is over more. The first third gets you halfway there. and then the other third gets you root 3 there. Okay, so then repeat, mirror on this side, and then again. So here's midpoint, so first third gets you halfway, and then a little bit, and then the first third gets you halfway. Boom. So here is our graph. All right, and for repeating it, my next 2 dots would be gap here, boom, boom again, and then down at the bottom, right there, and okay. So the key is knowing your parameters, A, B, H, K, finding your period, and then first third gets you halfway to your A. Right? We'll do one more. Do one more just to be safe. And then you can do some of the MHSs. Or watch the physics video, because that's also today's lesson. All right. Promise the physics video will be a little bit more entertaining than just watching me in the whiteboard. Last example. So let's go with y equals negative sine of 2x minus sine pi over 2 plus 3. Oh, you don't have to solve anything. Everything's given to you. I think one of my cats is actually going to the litter box right now. Whew, that's stinky. All right. So, A is negative 1. Negative 1. B is 2. H is pi over 2. And K is 3. Okay. Everything laid out. Let's solve. Period is equal to 2 pi over B. So therefore the period is pi. Now it helps if the period is pi and our H is pi over 2. It makes everything a little bit easier to work with. K is 3. So we know that we're starting at 1, 2, 3. And we only have to go up and down 1. So as I do this, I'm going to go here's 3, here's 4, here's 2, here's 1. And then our 0 is way down here. Okay, 0. Now, period is a pi, but we're starting at half a pi. So I have to go from half a pi plus a pi, which is 1.5 pi. So let's say here is half a pi, here is a full pi, here is 3 pi over 2, here is 2 pi, and then here is 2.5 pi, so 2 and pi over 2, and so on and so on. Right? So I know that K is my middle line. I'm starting at pi over 2. So pi over 2 at 3. All right? And then I know that I have to go over a full pi to get my endpoint. So a full pi is there. Wow, Grizzly, that's stinky. Whew. All right, and then in between is my other dot. And then I say, okay, do I go up or do I go down? Well, negative means I go down first. So in between these 2 dots is my first down of 1. And in between these 2 dots is my next one, up of 1. Right? And then the gradualness of the curvature says that a third is a half, and then a little bit, a half. A third is a half, little bit, half, boom, 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 boom. All right, there you have it. That is the quickest way to graphing a sine function. Now you can do some MHS.